Okay, so today we're going to take a look at percent of change, which is a change between an original value and a new value, okay? And usually you see percent of change with money, but you can see it in situations like what we have just finished up with, or in the midst of, with the quarantine and the virus, the coronavirus. So I'm sure that as you were listening to the news or hearing things on social media, they were talking about there was a 20% increase, or there was a 50% increase, or there was a 20% decrease in the number of cases of COVID-19. And this is actually a percent of change. Okay, so it's comparing how many cases of the virus we had yesterday compared to how many cases we have today. So the percent of change can actually be positive or it can be negative. Okay, it can be positive or it can be negative. So I want you to take a minute and jot down this formula, because this formula is super important, because it actually puts our percent of change into a proportion, which we know proportions are pretty easy to solve. It's just a basic equation. As soon as we can figure out whether it is an increase or a decrease, we know what we're looking for, okay? So obviously a percent of increase is going to be positive, and a percent of decrease is going to be negative. So it's really important that we make that decision based on the information right away, so you know whether your answer should be positive or whether your answer should be negative and what it means. Okay? All right, so now we've got that formula written down. Let's go ahead and get started. Okay, so this problem says we have to determine the percent of change, whether it's an increase or a decrease, and then actually find the percent of change. If I take a look at this, I'm going from 20 to 23. So obviously I know that is an increase. Okay, that's an increase because it's going up. So that's pretty simple. I can decide that without doing any math. Now, remember, here's our formula. Okay? And we need to figure out which one is the new and which one is the old. Well, original is our O, and then the final, which is going to be our new. So we have our new, which is 23, minus our original, which is 20. The original, again, is 20. I'm looking for my percent, and it's over 100. Now, this is pretty simple, because 23 minus 20, that's 3. So I have 3 over 20 equals x over 100. And remember how we saw proportions. It is a cross product. So 20x equals 300. So dividing by 20, I'm going to come up with 15. Okay, now I'm not done, because this is a word problem. So I know when I have word problems, I always have to label. Okay, and I was looking for a percent. So this is actually a 15% increase, because it went up. Okay, it went up. So again, remember, it's always helpful to look with parentheses when you're doing substitution. Okay, let's go ahead and look at this next problem and see if we can figure out what is what, okay? All right, here we go. Let me go ahead and just get rid of this plus sign here. We don't need that guy. But I do need an equal sign. Okay, read our problem. So the total number of passengers on a cruise ship increased 10%. So they gave me a percent from 2007 to 2009. If there were 17.2 million passengers in 2009, how many were there in 2007? Okay, so let's think about what we have. We need to have, for our formula, a new and original. And if I have a percent, the percent is going to go on the top, and I have the 100. So reading this, I see my percent. That's easy. So I know this is going to be a 10. Okay, that's going to be a 10. Now, if there were 17.22 million passengers in 2009, That's what I have to decide. Is that my new or is that my original? Well, if I look at my data, it's talking 2007 to 2009. So this is going to be the original. 2009 is going to be the new. So 17.22, I have to remember this is in millions. Okay, that's in millions. I'm going to have to remember that as I finish this up. I do not know what the original is. Okay, I do not know what the original is. So let's go ahead and substitute in our formula and look at what we've got. So 17.22 minus x over x equals 10 over 100. Okay, so this one's a little bit more complex, but that's okay. We're still going to use a cross product. So let's go ahead and write this out and see what we're looking at. So we have 100, the 17.22 minus x equals 10x. Well, that's not too bad. Why don't you take a minute and see if you can solve that equation for x? Okay, so if I go ahead and start solving this, 100 times 17.22 is 1,722 minus 100x equals 10x. If I keep going, I know I have to move my negative 100x, so I'm adding that. I'm going to go ahead and come up here. So 1722 equals 110x. So x, when I divide by 110, is going to give me 15.65. It's 6 by 4, but we're going to go ahead and round to 2 decimal spots there. Now, I'm not done. What is that? It's not apples. It's not bananas. It is millions of passengers. Okay, and that is an increase. Okay, that is also it was an increase, okay, because it went up from 15.65 to 17.22, and our percent was positive. All right, now let's take a look at what happens when we have a different type of problem, because sometimes we'll see situations where it's not really a percent of change problem. They're actually giving me a problem which is an is or an of, or a part and a whole. Okay, a part and a whole. So I can actually read a different type of problem and figure out, is it a new and original, or is it kind of a part and a whole situation? Okay, so if 60% of the student body wore red last Friday, then 810 students wore red. How many students were in the student body? Let me read that again so we can kind of think about this. If 60% of the student body wore red last Friday, then 810 students wore red. How many students are in the student body? So they're looking for a total. So if they're looking for a total, I'm really looking at this guy. So let's go ahead and set it up. My percent, 60. Here's my 100. What else do I know? I know 810. That is the part. Okay, that is the part. And I do not know the whole. So solving this guy, if I take 810 times 100, I come up with 881,000. And I have 60x dividing by 60. I come up with 1,350. Okay, 1,350 students. Now, here's one of the things to be aware of. If you do this wrong, okay, let's say that I switched it and I actually made my equation look like this. If I take 60 times 810 and I divide by 100, that's going to give me 486 students. This is not logical, okay? It is not logical. So when I mess up on these types of problems, my answer is ridiculous. I know that I'm looking for a total, and the total should be more than the other number. So there's no way that 486 students is my total. So I know that I didn't do that correctly. So be very cautious when you're working on these that you are actually solving them correctly. Okay? You're actually solving them correctly. Okay, so there are other types of percent of change, and specifically ones that we see all the time, and that is sales tax, discounts, shipping costs, things like that. Okay, so before we take a look at sales tax and discounts, we need to remember how to convert a percent to a decimal. Okay, so if I have 25%, I know that I need to move my decimal 2 spots. That's actually 0.25. So I'm actually dividing by 100 to change that to a decimal. So if I have 2.4%, 1, 2, that's 0.024 as a decimal. And even more important is if I have 0.3%, okay, 0.3%, I still have to move the decimal 2 spots. 1, 2, so 0.003 is the actual decimal. Okay, so 2 spots. All right, so let's take a look at this and see if we can figure out what to do. Now, there's a couple things that we need to remember. We need to remember that sales tax is always added. Okay, sales tax is added, and discount is subtracted from the price. Okay, and when we start making changes in values, we need to remember that it does impact the price. Okay, so there will always be a new price if there's a discount. All right, so let's go ahead and take a look at this problem. Marta is purchasing wire and beads to make jewelry. Her merchandise is $28.62 before tax. If the tax is 7.25% of the sales, what is the final cost? So Marta is purchasing wire and beads to make jewelry. Her merchandise is $28.62 before tax. So this is a price, okay? That's my original price. And 7.25% of the total of the is my tax rate. So I know that I'm going to be adding, okay, I'm going to be adding something to my original price. So we're going to go ahead and write down the original price here. Okay, write down the original price. The next thing we have to figure out is what is 7.25 as a decimal? Well, I know I need to move it 2 spots. So 0.0725. That is my decimal. So I'm going to multiply my original price times 0.0725 because I need to have my amount of sales tax. Okay, my amount of sales tax. So go ahead and do that and let me know what you get. Now remember, this is money, so we need to round appropriately, okay? We need to round appropriately. So I come up with 2.07495. Remember, money is in hundreds, okay? So it's the second decimal spot. So since this is a 4, that 7 is not going to change. The amount of sales tax is 2.07. Now, the next thing it's asking is what is my final price? The final price is how much you're going to pay when you go up to the register. Well, I know that I have to add that back to my original price. So 2.07 plus 28.62 is going to run me $30.69. So my total is $30.69. Now, again, this is logic, okay? So if I make a mistake, and do not get my decimal right, all right, I don't get my decimal right. If I was to have multiplied this times 0.725, my tax would have been $20.30. Now, that's not logical. Okay, it's not logical that I'm paying $20 in tax on a $28 item. So again, be thinking about whether or not your answer is logical. Okay? If it is logical, you're probably right. If it's not logical, you did something wrong. So think about the reasonableness of your answer. All right, now let's take a look at this one. So this one has got a sale, which means it's a discount. And remember, we said discount is subtraction. But this one also has a sales tax. Okay? So a new laptop is on sale for 25% off of a price of $600. So here's my original price, $600. And I'm going to multiply it. Well, 25% as a decimal is 0.25. So I'm going to multiply that by 0.25 because the first thing it's asking is how much money will I save? So 600 times 0.25 gives me $150. So I'm saving $150. So what is the price? What is the price now of my laptop? So to find that, 600 minus 150. So original price minus my discount, 600 minus 150 is going to bring me to 450. Okay, so this is now the price I use. I'm never going to use the 600 again. I don't pay tax on the original price. I pay tax on whatever price that the current item is. Okay, so it's always taxes paid on the sale price. So tax, again, 7.89. 7.89 as a decimal is 0.0789. Remember, that's 2 spots. So 450 times 0.0789 gives me 35.505. Okay, so what do you think the tax is? Do you think it's 35.50 or 35.51? If you said 35.51, you are correct. This is a 5. It's going to round up that 100th spot. Okay, they're not going to let you keep your penny. Believe me, they are definitely going to have you pay it. So my amount of sales tax is $35.51. Okay, now what's total cost? Well, my original price was $450. My sales tax is $35.51. So I'm going to add those together. I come up with $485.51. So that problem is complete. Okay, so I think should be good on those. The only other one I want to talk about is, let's say that I have, I bought a car. Well, let's not do a car. Let's say that I bought a stock. Okay, I bought a stock and I paid $300 per share. And now it is only worth $200. Now notice how this one is a decrease. Okay, it's going down. Let's go ahead and take a look at this one and figure out my percent of change, because this one's negative and I want to make sure that you are comfortable with how to deal with a negative. So new minus original equals percent over 100. So my new is 200. My original was 300. And here's my 300. So notice I'm going to come up with a negative here. So that is a negative 100. So that's important because that tells me this is a decrease, okay? So negative 100 times 100 divided by 300 I can punch this in, right? Negative 100 times 100 divided by 300 gives me negative 33.33333 repeating. Okay, so this is a decrease. So since it is a decrease, I can do this 2 ways. I can write it as 33.3% decrease so that it says it's going down, or I can also write it as a negative 33.3%. Okay, we normally see it this way, but this is actually also accurate. but you need to realize that it is a positive or a negative, okay? So watch for that. Watch for that negative. That will tell you whether or not something is a percent of change, either increase or decrease. Now, there's also a foldable that goes along with this. You might want to take a look at that. It has some formulas and some examples on the sales tax pieces if you're still struggling with that. And we will catch up with you tomorrow. Have a good rest of your day.